Hello, welcome to another session of game development. Today we are going to continue with the animation. So we will create the new animations, specific animation classes for the the game Hangman. So let me show the Hangman here. Launcher, this one. Okay, so it's preparing, launching the game. So we have a. Let me adjust the sound because it's too high. So sound here. Mm, Let's try again. A little bit. Okay, this is the previous game I prepared. It's called Hangman, and in this second scene it has an animation. So this animation has three steps. So walking to the right, firing to the front, going to the left, and firing to the right. So there are four animations. So basically, it starts switching the animation. So the NPC character. And let me show you the picture. So we have our animations too. Okay, here. Okay, no, animations one. Okay, and this is the different positions of the um, of the animation of the character. And what it does is just when the animation starts, it starts changing from this picture, so from this area of the picture to this one, again and again, and again the loop, moving to the first of the loop. So this is more or less the animation, and the 3, 6, 8 positions for the animation of the character, and going to the right, and then it runs the fire. This one. If it's the 0, 1, 2, 3, 4 in the fourth row, so it has the fire to the front. Next it goes to the left, so it's the second row going to the left, and then it fires to the right, so it's this position. And what is different is that this is done here on the left most position without moving the x coordinate, and this one is updating the x coordinate. So what we need to do is just to prepare an animation that can switch the picture when the movement starts. So let's show what we had from the previous session. So in the previous session, we were working with animations, and we worked with Secret, another game. So these are some animations, just changing all the. This is the window one, is the bugger, and I made three different animations. So this is the minimize, maximize, rotating, and another one just changing the sizes. So these three animations, whenever they are called, just clicking this button, they start some keyframes. So for example, in order to minimize, there are only two keyframes. So this is keyframe 0, and keyframe 1 is in just null positions in 0, 0, 0. So it's just a linear interpolation. Okay, so there is a second one there. For the maximizing, it maximizes and then rotates. So there are several key positions. And the next one, it's mm, it's doing several. So let's move to how it's done in code. So and the code is just showing, it's just trying to interpolate between the keyframes. So what we need just is to provide at which position, at which size, and which size do you want for the window. So it's scene 2, scene 2, this F effect. So let's move here to the right. Okay, so this is the animator, the animator class. The animator class has, it's here, the animator, yes, animator class has different methods, but mainly it's a list of animations of a standard one. If the E animation is just an interface, so it's what it must be implemented, but by any animation. So at the moment we have different ones. So right now we have um, this one, the linear float. So it was used just to create just a more generic version, just implementing this interface. Then we created the same one, but using keyframes. So there is, in the linear float was the first version, just one linear interpolation between minimum and maximum value, between minimum time and maximum time. And the next evolution or next version of the animation using also floats, but it accepts at least an array of values and an array of keys. So it interpolates between two consecutive values and keys. And the next one is the animation keyframe, and this is the next one, and this is a list instead of an array. It accepts a list of any type of object that implements that interface. So this is more generic version that accepts anything. So we are using this animation keyframe type of animation to implement the different effects for the windows. So as I said, the animator is just a list of animations. So we have one, maximize, this one that change the sizes, and the next one is minimize. So what it needs for the animation is just some keyframes. The keyframes are a list of keys. So this is the time. So at 0, when it starts the animation, I want these values for the window position. When it reached to second 1, I want these values. And at second 2, the final second of the animation, I want these values. And between these keys, these keyframes, it interpolates using linear interpolation. So between here and here, for example, let me check. For example, the width here is 0 and here is 1, so it interpolates. If it's at 50, 100%, so it's 0.5 and whatever. Okay. For example, between this one and this one, the only change is the rotation. So it rotates the window, all the window. This is P over 2, so P half P. Half P, so it's 90 degrees clockwise, so from 12 o'clock to 3 o'clock. So it's the rotation that it's done between here and here. If we change this one, for example, if we set just P, so it will put the window upside down in the maximize animation instead of rotating only a quarter. So, okay, you see that it's instead of 90 degrees, it's rotating 180. Okay. The next one, it's important in order to, as you can see, that all the animations in the series must be reusing the last step. So it's important that from one to another that you start with the last frame of the previous animation. If not, you can see these switches. So, for example, this one is upside down, and then the next one uses the other position, so there is some issues here. Okay, so all of this must be done for the other game, for this one for Hangman that is using a previous versions of this one. So and the first thing that we are going to do is just to check what is done in Hangman. Okay, I have changed zones. Perfect. Zone is scenes. I think it's scene 8. Scene 8 has here an animation and the other one. So it has two different animations. So this is in order to animate the X position, and this is in order to animate. Oh, sorry, this is the X position, the X-axis, and this is just to change the tile. So mhm, this is just to change the tile. Okay, so this 0, 1, 2 till 7 and then again 0 is what I have shown about the animations. So mhm, when it says 0 is this one, 1, 2, 3, 4, 5, 6, 7 and again 0. So this is a complete loop. So it's important that we end with the rest position that is the first one. So that's why we use it twice at the beginning, at the end. So what we want is just to create an animation to replace this one. So let's start. So we can start with the keyframe. That is the so here what we need is just an integer. So we need to provide an integer. So we need to provide a tile index. So if it's 0, 1, it's what is needed. Mhm. So we can use, we cannot use this one because this type expects an object. So okay, it could be done, but I think I'm going to create a new one because the interpolation here it's very different. So let's move uh, here just to draw it. Okay, how it works. So if we have mm, if we have here just mm, a diagram with the this is usually is the time, and this can be, for example, the X position. So it's in the scene, X is where it's drawn from the left, so this is X. Okay, so you can say, okay, the keyframe at the beginning, you start with the minimum value, and when it stops the animation, it finish with this value. Okay, so you can in the middle, if you need these values uh, at some point in between. So if we need the value here, this one, change color. Okay, no, this one. Okay. If we need the value here, what we do is just interpolate the two positions and we get this value. This is a linear interpolation, what we call LERP. Mm, linear interpolation, it's not working, I cannot write, why? LERP, this is the linear interpolation. Okay, if we have keyframes, it's more or less the same, so no big changes. With keyframes, we have, instead of only the beginning at the end, we have between at any point, we have other values. So in this case, so at the beginning it could be this value, this value, this value, and later at the end this one. So we just, between here, what we do is just interpolate between the two keys that we are positioned. It's our position. So if we are here, we interpolate between these 2 points and we get this point. So it's just linear interpolation. What's different when we need uh, the index? So if we have an animation with some positions, just saying, yes, more or less. You imagine that we have an atlas with different positions, so we want to change. So we want to start with 0, later with 1, later with 2, just to be like an animation. So instead of these ones, there is not linear interpolation. So more or less, what we need is just the same keys. So the keys is which index is needed at each point. For example, at this case, so if we start, we want the index 0. So we start with 0. And at second one, we want the another one. So we want 1, later we want 2, and then we want to go back, just repeating again and doing a thing like that. So 0, 1, 2, 1, 0. This is the animation. What happens when we need a value in the middle of 2? We cannot, okay, it's possible, but it's not in this engine, it's not created. We cannot interpolate two pictures. So what we need is just to choose one of them. So what to do? It's what we can use is just to say, okay, just till the middle, use the previous one. And when we reach more than this, the middle of this time, use the next one. So we can create this type of step function just to provide the information. The problem here with this type of animation is that the time for the pictures in the middle is higher than this one. So maybe we need another approach. So we can say, okay, we have this picture 0 at 0, and at 1 I want to change. So it could be this way to say, okay, this time, hmm, this time is use always. This will be just use the previous one. So use the previous one, use the previous one, and this animation we are not using never the last one. The last one is just dummy because it doesn't matter this value. We are always using the previous one. So it will never, so maybe we need to duplicate, to add an extra step just to duplicate the last step. that could be a solution. Just use, but and the way we provide the information, it's not, for example, if we say, okay, use 0, the tile index 0, uh, and we set the time at 0 seconds. Use the 1 when we are at second 1, and the 2, for example, at the 4th second. So if this is the start of the animation, the first one is 0 seconds. So we can set that this is the, say, okay, the tile index and its duration. This could be that one, the index and duration. It's a possibility. That's an option to say, okay, this is, but in this case it could not be 0. So it could be, okay, I want this one, and this 2. This is an option. Another option is just to say, okay, okay, I'm changing. Why I cannot change? Let me change the color here. So another one is just to say, okay, I want the index. I want the index, but instead say, okay, when it switch, when it change, when, or the start time, and that way it will be, okay, the thumb, it will be start time. It will be 0, and it starts at 0 seconds. Tile 1 will start at second 2, for example. Tile 2 will start at second 4, or whatever. So instead of the duration, just to say the absolute time on when it starts. So, and again 0 will start at 5 seconds. So the start time, it could be the start time. The start time is more or less what we are using in here. So this linear interpolation that we are using right now, it says so. So at 0 seconds, you have the minimum value. At maximum seconds, so at the end, at 100%, or for example 6 seconds, you have the final value. So it's more like the time is absolute time. It's when it happens. It's the time of the keyframe when it must be. So so this means 0. This picture will remain 2 seconds. So it's always to choose the previous one, and you need an extra dummy. If you want to end with 0, we cannot. You need an extra one here just to say, okay, an extra one to say I want that 0 picture remains there 1 second, because it's displaying the previous one. So it's not easy for the pictures, because we don't have linear interpolation. So if we use the first approach just to say, okay, just round between, so between 0 and 2 seconds, if you are between 0 and 1, choose 0, and between 1 and 2 seconds, choose 1. That's an option, but it's very difficult just to provide the information, because you need to manually calculate when it's going to switch. So maybe it's better just to say when it starts, when that new tile will be visible. So tile 1 is visible at second 2. Tile 0 is visible at second 0 till there is another one. So we will choose this one. And the problem with that is that the last tile index is not used because the animation ends. If the animation ends, it's never used. It provides the previous one. So you need to duplicate it. Hmm. Okay, so I think that we are going to choose this approach. I think it's not the better. I don't like to repeat the last animation, but I think that we need because we are using the time, the absolute time, just to provide the keys. The keyframe time is absolute time, so we are using this second approach. So just to keep the same philosophy, the same way with all the animation, we are going to choose this one. So let's move back to code, and let's try to do that. So we need a new class that it's going to provide just an integer and that will accept some absolute time. So it's not this way, it's different. So I think that we can reuse this one. Okay, let's create a new one. Animation keyframe. So new class. Let's call like animation keyframe, but is tile index tiles. Keyframe tile. Yes, okay, that way. Okay, it implements our interface. Okay. Oh, no. Sorry. Okay, and I think now it lets me insert this one. Okay, the first one is just this. I think that we can reuse. Let me close this one because we are not using. We are basing this new class in this one, so we can copy some of the properties. So the animation name, the loop times, and this is not floats. It's an integer array. Okay, yes. So the get name is the same. So get name is just to provide the name of the animation. No changes there. So get animation, get name is just get name. Okay, we need the getters and setters. We can copy also them. Get animation is just get animation name. Okay, this is done. The next one is reset time origin. This is the same for all the animations. We can reuse. Okay, animation time origin and what not is not there. I have missed. Okay, it's more or less the same. All of these um, animations. So we have the values that in our case will be the tile, the different pictures position in the atlas. So picture 0, picture 1, picture 2, whatever. the pictures, and the key is the absolute value. So is the absolute so up time from the beginning of the animation. Okay, so we have the get name is there. Okay, the reset time origin is there. Okay, and we need all of these ones. So let's start with the percentage. Okay, I think the percentage is the same. So percentage is calculated based on the keys. So we don't need, it doesn't matter the type of values because percentage of the animation is based only on keys. So this is the same. Mm -hmm. Okay, let's review the code. Animation duration. Okay, I need to copy that one. Okay. Okay. In previous versions, it was more complicated to calculate the total animation duration because you need, for example, in this case, if you say, okay, this is the time for each a picture, so in order to calculate the duration, you need to sum up all of them. So you need to do a loop in order to sum up all the key values. But in the case that we are just provided the absolute time, the animation duration is the last key. So if the last one was 5 seconds, so do something at 5 seconds, that is the last value. So this is the number of keys minus 1 because we start the index with 0 instead of 1. So that's why we need always to subtract 1 to the index array. So in order to calculate where we are in the animation at with percentage of the animation, what we do is just to check. We check which time is right now. So right now minus the time the the origin. So when we start the animation, we set uh, we save which time is it, and we just subtract. So just to know the lapse time from that animation start. So what we do is just we calculate in which loop we are. So just because we can have an animation that is infinite loop or it could be just multiple loops or whatever. So if the current loop is lower than the number of loops, so for example if it's 5 loops and this is it's only one, so no problem, you just calculate the lapse time. You need mm, to do an integer division and get the remaining value. So you get the lapse time and divided by anim duration, and you get a float value. The integer part of that float is the number of loops, and the dot dot whatever. So the decimal part is the percentage. The percentage is the remaining, and when you divide by the total amount of the animation, you get the percentage. Okay, so this is just more or less a trick. It's just to provide if that's the last loop. So it's the last loop plus one. We just say, okay, we are at the end of the loop, just in order to provide that the loop has ended to another functions because we are checking this function not at every millisecond or every nanoseconds. We are just checking this at in regular intervals. So, for example, every 16 milliseconds, it could happen that the last time that we check this function, the percentage was 99.99999, and the next time that we check it, it's over, so it's providing null because it has completed the last loop. So if we need to get the 100% for another functions, just to say, okay, I need to get the 100 value because I need that to check that the animation has ended, it's important just to provide this trick just in one loop again. Okay, so percentage is completed, and now is animation ended. I think this is ended, and is ended is the same. I think that we can copy this one also. Mhm. It's more or less the same. Is ended, so we get is ended. Is ended. Where is ended? Is animation ended? Time. Time. Okay. So what we need just what is different just for this new version, what we need to provide is just the animation value, just to provide the tile for each different time. So in this case, we provide. Okay, let's copy and implement the function. Okay, so get value and create a method. This is what we need to complete. Here, for example, so okay, so we get the value. This one, what we did. Okay, I think that we can reuse all of this one because the value, what we need to get the first information that we need to get is to know between the two keyframes where we are between two keyframes, so we need to calculate the keyframes, and this code is doing all of that. Yep. So copy. mm, So it's the same code. So of course we don't want to provide. We want to provide an integer. Integer. Here it provides an integer. Okay, because it's the tile index, it will be 0, 1, 2, but it cannot be a float. So we start, we use the animation duration. Okay, we know the wall animation, long how long it is. So maybe imagine that is 6 seconds. So with this one, we need the time inside the loop. So we subtract the starting of the animation. Uh, we calculate the remaining. So if you are over one loop, you subtract the whole loop. For example, if you are 7 seconds and the loop is 6 seconds, you 7 minus 6, you have 1, so you are inside the loop again with 1 second. So that is the inside loop time. So it's just loop again and say what is the time inside the loop. So inside loop time is lower than animation duration. This is calculating the current loop. Current loop. Current loop is okay. This is important because if it's higher, we don't care. If it's higher than the loops, so if it's only one time animation and we are over, so we are greater than in loop 2, 3, or whatever, what we are going to provide is just here we need to check this one, which one we are going to provide. So in our case, as we have said, we want to provide okay, it could be the last value, but what we have agreed is that it will be always the previous value. So always the previous value. So we cannot provide the last value. The last value is just dummy. So we need to check that also inside. So we have the percentage inside loop. Okay. So why it's claiming here value cannot come from loop to integer. Okay. These values it's no. Okay. Okay. So here what we have is just we have two keyframes. So we have keyframe lower index and keyframe lower index plus one. So we are between these two keyframes. We when we did linear interpolation, we did here. So just use the minimum value, the left value, plus the percentage of the range of values. So this is just linear interpolation. But right now we don't need this one, so we don't need the percentage because in this case what we are going to provide is always the previous value. So what we want to provide is always, if we are in an interval between two keyframes, what we want to provide is the left keyframe value. So I don't care about the right keyframe value. So it will be uh, used for when the absolute time reaches. Okay, so here we use only use left keyframe index. So it's what we need. So I can. So we don't need these ones. Okay. So instead of doing any linear interpolation, this type of animation, we cannot choose between two indexes. So we are going to use the left one, the left keyframe index, and that's why we also instead of -1 we set -2. Okay, so I think it's all done here. So then what we need is just to try it. So how to try it? So we need to move all this information to change the format of these ones. NPC anim tile because it's using the old animation instead of components animation. We are going to use right now this one, the animation keyframe tile. So we want to change this animation, and later we can change this one. So let's start with this one. So let me create a new one. In the scene 8 we have NPC anim tile. Okay, let me just do a copy and overwrite. So instead of components animator, it's the new one. It's called animation package animator, and we use also the animation package, and the new one it's called this name. This is the new class that we have just created. So the name, I don't care about the name. To the right, this is the animation of the right. Okay, and there are no types here, and we need to provide an integer of values. Okay, so this the in the pictures. Where are the pictures? Animations. So this is this. It's very small. 0, 1, 2, 3, 4, 5, 6, 7, and again the 0. But as I said, we need uh, a new one for the duration of the last one. So, and here we will start with 0. Okay, so this means that the first tile, 0, will appear at second 0. These are seconds, but they are, okay, it's not a second, it's 100 milliseconds. So at 100 milliseconds, start or display tile 1, this one. Uh, in the past it was the duration, but right now it's the absolute time. So at 200 milliseconds, and displays the tile 2, 300, 4, 5, and I will do that. I suppose that all are in milliseconds. 8, 9. Okay, so 3. Okay, so if it's correct, and this is the absolute time, and we have 3, 6, 9, 10, and we have from 1 to 9 and 0, 10. Okay, we have 10 and 10. Okay, in order to check this one, I think that the first what we can do is just remove the other animations and just keep only one and work only with one. So this is to write, keeping the old types of animations, and this is using the new class. So let's remove all of this and just keep only one animation. This animation is just go to the right, and when it will reach the far right, it will start again from the left, again and again. So let's try this one. Okay, so this animation will work. This is an entity, and let me check the rules here. I want to check for npc anim tile. Strange, it's not here. Why no? npc tile. Okay. I need to check where is it used. npc anim tile. Okay, this is the entity. So let me look for that. Okay. The tail, when it's loaded, the scene, what it does is just call animator and select first animator and first animation. So this is select first animation. It's the same, so no changes. Strange. I don't know where it requests the new one. NPC tile, and what's not displaying this one? Control F. Fine. Here. Okay. NPC X animation switched. So when there is a switch when there is a change in the second animation, it does here a switch animation. So we have that here, switch animation. Okay, it's called here next animation. So let's switch this one. Change the method. It's called next animation. And instead of components animator, right now we have changed and the package and its animation. And it's called animation animator. Animation animator have a select first animation method. Okay. And it also have a next animation. So let's do try. Oh, no, not that game. I want to check this one, the hangman. So let's check what happens. First of all, if there are no issues. Okay, it's not switching, as you can see. It's not changing the tile. It's always the same tile. It's always zero. It's always getting zero. And there is a null pointer here because I suppose NPC. Okay, auto update. Okay, there is NPC tile. There is another one. We have not seen that one. Here, there is another one, auto update. Instead of auto update, and right now it is get animation value. Mm, okay, let's check if there is any error. Okay, another error here. Components animator get. Okay, I have changed only the method and not the package animation. And let me lower the volume. So it's scene 0, scene 1, scene 9. The sound. Okay. Okay. Why? I have not changed it. Animation? No. Animation animator get animation value. That's it, yes. NPC tile. So let's move here. NPC tile is using NPC anim tile. NPC anim tile. It's animation, animation, animation. Correct. NPC tile, animation, animator. Here, animation, animator. Get animation value. Get animation value. Yes, that's correct. What's happening here? No such field, but okay. It's not working because when I have built this one instead of state name in the new classes, it's called animation name. If it cannot build correctly the objects, then there are some issues. Again, more mistakes. No such file. Animation. Animation. What it means with animation. Here. It's not animation. Right now it's values. Values and keys. And values, keys. Okay. Try again. Okay. There are no mistakes right now, but it's not changing, so we get always 0, always getting 0 from the value. So animation, let's put some traces here, so I don't need this one. We always getting this first picture and there is no change, so without changing it, it's not giving us the effect that it's working. So it's calling get animation value, so it's providing the time. And we provide output, and the output is always 0, 0, 0, 0, 0. Okay, why? because the percentage is always 0 also, because we have not reset the time. When we select the first animation, we need to reset the time. Select first animation. Select first animation. Select next animation. Okay, this is the issue. Select first animation. Okay, let's add here. If we do not reset the time, the animation, the initial value of the animation, I think it should be undefined. It's better just to provide any error right there. No, it's not moving. It's always 100%, so it's always at the end of the loop. Okay. One important is that we have not provided the loops. If we do not provide the loops must be 0. So this is a new parameter that we have added. So this is an infinite loop. So this one. Okay. So let's check. I have seen it moving. No, it's not moving. Why? And at this moment it's provided null and null. Let's change to 1000 loop times. Okay. And why with -1 with infinite value it's not working? I need to check why the infinite loop is not correctly. So this is the animation. What is doing, you can see on the, let me move it a little bit, this one. So on the right in the console you can see the outputs. The output is just showing which tile is shown, so you can see very quickly 0, 1, 2, 3, and the next one is the percentage of the time of the animation, so it goes from 0 to 1. So let's stop and see how it works. So for example here, so okay, this is the end of the loop. So here when we are at the beginning of the loop, so it's more or less 100%, 3%, we are providing the value 0. 0 means just choose this picture. When we move a little bit, so if you remember, the time is what we have said is that after 100 milliseconds, we want picture 1. So what it does is just during 100 milliseconds, it provides picture number 1. So more or less, if I can see, 100 milliseconds is 4 updates of the drawing function. So during 100 milliseconds, there are 4 drawing calls. So we get 4 zeros, 4 ones, and 4 twos. In this case, 5. Okay, it depends on the machine, the updates. It depends a lot of things because not all the frames take the same time. But more or less, you can see that as the animation is increased, the percentage of the animation, it switch to the next tile, tile 5, tile 6, 7, and at the end of the loop, okay, and this I think it has been ended because there is another animation that is the going from left to right, and when that animation ends, force this animation to restart. So here we were at the 81% of the animation, so we still were running this animation, but someone has said, okay, restart the animation. So that's why we have started at 2% and again and again. So let me check if there is some animation ended here, for example. 4 sixes, 3 sevens, 0, 1, 2, 3, 4, 5, 6, 7. This is the 7 picture. And then at the end, at 91%, 93 till 99, we get the style 0 because we want to end the animation at the same position that we have started. We want to keep it at the rest position. As you can see, we cannot rely on the 100% of the animation because this is a it's not continuous because the drawing happens every 60 milliseconds or 15 milliseconds. So it's nearly impossible that you see here 100%. So here you have 99%. So it's very difficult to have 100%. So that's why we have added here some code. Let me show it back here. So when you end the loops, we have an extra loop here, just providing the last one. Or in the get percentage, for example, after if the loops are over, so if it's a 2 times animation and we are in the loop 3, so when it's loop 3, we provide 100, so it's fixed. So it's just to provide here 100, and that's the information needed by other functions just to say, okay, the animation has ended. So if the loop ends, here we will start to provide the last value. For example, it will be 0 and 1, 1, 1, 1, 1, 1, 1, because this is the extra loop, just providing that. And in the next loop, we just provide null, so there is no more animation. So just one extra loop just to provide the 100% because it's the only way that I have found till the moment so far, uh, just to provide the 100%. If not, it's nearly impossible. So here is 99.18, and if you see other 99.51, so very close to 1, but it's impossible to get the 1%, the 100%, saying that this is when you have finished. So right now it's working. So it's doing only one of the animations. If you remember the original one, or maybe here on the on the corner, and you can see right now in the mini window the original movement. So it has walking to right, walking to left, and firing twice. So we are going to add all of these here. So this is the updated one. So let me find the previews. Okay, this is Firefront. Okay, so let's migrate this old animation using the new one. So let me use the new code because there is very different. Okay, this is the old package, components animation, and this is the new one, animation keyframe tile. So the name, yes, the name, we are going to use the right name. So it's Firefront, loop times, okay, and it's only one, but okay, no, this is not the the correct. Let me check, it's the other one here. I have copied from the movement instead of the changing the pictures. So here are the pictures. So we have Firefront, okay, loop times, okay, leave that way, and these are the animations, the picture indexes. So we are going to add that extra picture at the end, and with the times I think it's more or less the same, but we need to change it to absolute position, absolute time instead of increments. So 1, I suppose this 2, 3, 4, 5, 6, 7. Okay, this is only 700 milliseconds. The walking is just 900, one walking cycle, and this firing is lower, so it doesn't matter. Okay, so let's check if just doing that change. We are going to see strange things because we are going to see how it fires as he moves to the right, but this is the walking animation, and right now is the firing. The walking and then the fire animation. Okay, fire only once. Okay, so it's working. So let me add the remaining animations. So here we have okay, okay, two remaining animations. These ones. Let me copy a good one. So we change the name. This is to left. It's one. Okay, let me keep this. We need to add. Okay, this is to left. This is infinite. We need to repeat the last one. And the times, I suppose that more or less the same, but let's increment. So 100 milliseconds, 200, 300, 4, 5, 6, 7, 8, 9. Okay. Okay, so this is done. And the last one. The last one is fire left. Loop times is once only. These are the key tiles, key index tiles. Let's repeat the last one and the time. 100, 200, 300, 4, and 5. Okay, so the animations are here, and what I'm going to keep or to put back is the animation moving to the right and left. So this is the second animation, this one that we remove just to leave only one. So okay, it's important that if you use if you animate two with two different parameters of one animation, they need to have the same amount of time. So this is the total animation going to right, going to left. So it's 3.5, no, more or less. Yes, 3.6 seconds, 3.6 seconds. And this is the animation firing, so fire to the front, so it's 700 milliseconds, and here 500 milliseconds. It's important that more or less it's the same as this one. Okay, so let's check if we get what we had in the past, but using the new animation classes. Okay. Okay, so we have the same that we had in the past, but we have migrated the classes to the new one. So this is this is working. What we can do just so okay, it's working. Okay, so we have the new version of the tiles of just showing changing. So this animation, what the only thing that it's doing is just to changing the pictures. So changing the pictures is the only thing that it's doing. So it's doing this first animation. The top row is going to right, and the second row going to left, and the fire animations is the 1, 2, 3, 4, the five. The fifth row is the firing to the front, and the sixth row is the animation firing to the right. So it's working fine. So let me remove some. Okay, I think that I need to check what's happening with the infinite loop, because if you remember when we said here -1 it's not working. So let's check what happens why going to right with infinite loops is not working. It's not working, not the first time. So let's check the second time. No, it's not working. Okay, let's check the code and where is that. So animation get value. So right now where we use mm, the loop times. Oh, okay. If current loop is lower than loop times. Okay, so -1 is not a good value. So for infinite loops, so if current loop, okay, so we need to add here another condition, because it's difficult to say. Thank you for the follow, Dmitry Maximov Gala Galahad. I expect to pronounce correctly. So when you have infinite the loop times, I have choose -1 just to say, okay, if it's negative value, it's just infinite loop. But maybe it's not the best one. Maybe it's causing some issues in the condition. So we can add here some code. So let's, okay, in order to reuse or change the behavior without modifying all the code, so we can create an auxiliary function. So it's infinite loop. So because this way we can change the behavior of this -1 whenever we want. So it's infinite loop. So this just return if loop times equals -1. So using this one, if I change my mind later and instead of using -1, I use the maximum value, the maximum integer value, because you can say, okay, the same saying integer dot max value, saying, okay, this is the maximum value. I think is 32 million, so it's enough. So it's just or just something that you choose. So let we add here and we can change all of them. So in this way, if the current loop is, if we have not reached the maximum loops in order to animate, okay, or if it's an infinite loop, please keep doing it. So let's copy this code. Okay, I need to add this code to the other to the previous animation, because it's doing it incorrectly also. It has the same bug, but this is the first time I have seen it. So here, if here it has the same bug. Okay, so let's try again so it will work, and we are going to check some strange things about not coordinating the different animations. So right now it is working. I hope it's the infinite. Yes, it's the -1. Okay, and it's working. So so we can use right now -1 just to say that is an infinite loop. And let me show what happens, because going to the right it takes 3 3 and 3.6 seconds. So you need to provide this walking to the right animation at least 3.6 seconds. So what happens if this that is more or less 0.9 seconds, if I provide only once, what will happen? Because the time of the two different animations are not the same. So it will do strange things, that it will do the animation only during the, okay, as you have seen, the animation it takes only the walking to the right, it's done only once, and then it stops, but the movement to the right continues, so it's doing not good animation. So you need to synchronize both. So if the walking to the right or to the left is the animation that is saying when the animation ends, you need that the walking to the right takes, or it's longer, it takes more than the expected value. So this yes, you need just to provide greater than that. So infinite is it's okay. It's better, if they are the same. So if we have here it's 900 milliseconds, so it's more or less uh, um, I think, okay, this is 4 times, so okay, this is an exact match. So we repeat the walking to the right 4 times. 4 times 0.9 is 3.6. So it's very important, because that way, instead of uh, stopping with one leg in front of the other, or moving, we stop with the rest position, so it's what is expected. So that's important, and just to synchronize both animations. So this works. So let me check what we had for today. So create animation classes for Atlas images. This is done. Okay, and we have migrated only one. Mhm. Okay, let's just migrate the next one. The next one is just to animate the the X position. So this is the first one. Animation is just changing the pictures, so it's just changing these pictures. And the other one is moving to the right or to the left. So in here, if you see the minimum value, so walking to the right is moving from 0.3, the 30% of the screen. So this is in percentage of the screen. So from 30% from the left till 60% of the screen, moving from left to right. So maybe it's better that's this way, from 30% to 6%. When you fire to the front, you do not move. So the value is the same. So you are just stand there, just fire. So it's only a change in the pictures, but you need to keep this one, because you need to remain in at this position and not start the next animation. You need to rest here the same time that it needs, just to show the pictures of the firing animation. So it's just be there. So linear interpolation between the same value, it's always providing the same value. So you are there at the same position. So no changes. It's the same when you fire to the right. So here is the same. So you are resting on the left of the animation, and here this is the animation walking from the right to the left, so it's the same. So we are the starting value is 60% of the screen, and we move to the left of the screen to the 30%. So it's the same as this one, but in the opposite way. So this is just providing the X animation. So the, mhm, from left to right and left to right, stop, be there in rest position some time to fire, then going to right, from the right to the left. So this is the animations. So just to change this one, this is the old one. So let me do a manual copy of this one just in case. Okay, so I think it's too bigger for me. So we are going to use, this is the new animation, and what we are going to use is this, the linear floats, because this one. This is just using the mean and maximum values, so there are minor changes. So we need the loop times, so let's start changing. Instead of components, we use the new package, animation. Mm, and the class is called animation. It's just a linear interpolation of floats. So the name, okay, we need to do some minor changes here because I have changed the property names, so there is no type. This type is one of the reasons to switch to the new classes. Let me show the old ones. The old animation package, it was more or less the same as the new one, the Animator, but the animation, it was starting to be weird, to have to strange things. So here it started to have things like this one, and get animation value. Depending on the type, you have different behaviors. So after adding the third one, I said, okay, we need to refactor this one because it's not a good idea just to have types inside of the animation. So what we can have is different classes for the different types. So this type right now is an animation, a type of animation. This is another one. This is another one. And when you use different or multiple different types of classes, but you want to manage all of them as if they are only one, what you need is just to create an interface. So all of them, Animator knows how to manage an animation that implements these methods. So Animator calls get name, reset time origin, get animation value. It's calling only these methods. So this is an interface. So the Animator, it doesn't care about how it's managed any animation type, just to provide the value. So this is the way that it works. So I can show it later with a picture. So this was one reason just to move to a better ones, to different animations. So instead of having classes and classes types, subtypes, here a lot of conditions. This is not good programming technique to have all of these ones. If you have too much nested types, or here inside you can move this to different classes with different behavior, and just to have one interface just to provide the behavior. So this is, as the same says, is just a linear interpolation of floats without keyframes. So this is important, without keyframes. So what we can do is just, instead of using this one, so this one, what it does is yes, is it has as we can say that it has only two keyframes, the minimum and the maximum, two keyframes, and between the both keyframes, what we are doing is linear interpolation. So just calculating the middle point. We have another one, not this one. Yes, we have this one. We have this one with keyframes. So with these keyframes, we can provide the same behavior because we can say, okay, going to right is starting at 0.3 during this time, at this time, the next one, 0.6. Later, the another keyframe is this one at this time. Later, the next keyframe. So all of this one can be moved to only one animation using using keyframes because as I said, the starting point and the last point, the starting and the stopping point are two keyframes. So we can have uh, each starting and stopping point uh, moving that to a keyframe, and we can have only one animation here. And not sure if we can have the same here. Yes, I suppose not, because this is an infinite one, so here it's not so easy. No, it's not so easy because if we can do it manually and say, okay, this is for loop times, but when you start with using loops, it's not easy. Okay, I'm going to keep it as four different animations because instead of keyframes, so float array of keyframes, because when it stops one of this animation, it calls this animation just to move to the next one. So that's the main reason, just to keep it as different animations. And it's easier just to add another behavior. So after changing this one, I'm going to add a new behavior just in the middle, or just to show how easy it is to add new animation. Okay, so let's continue changing this one. So I have changed to package animation, animation, linear float. Okay, this one, yes, it's more or less the same. It's not using this one. Minimum value, maximum value, minimum time, maximum time, and the loop times. Okay, I need to add the loop times. Loop times 1, it's important. 1 because it's adding this one. I have another option just to say, okay, to say this is 900 milliseconds is the time that it takes to do complete walking to the right, and say that we need to repeat it 4 times. So it will be another option. So it's the same 4 times. Okay, it's not good. 4 times it will do the loop 4 times. So it's not a good idea. Let's move back to 3.6, that it's 4 times for the other animation. Okay, so just copy this one in all of them. The new package, new package, new package. What else? The name is animation name, and we do not use type. We do not use type. Animation name, and I need to add the loops. So one loop walking to the right. Okay, it's one loop for any of them. So let's move this way, the minimum value, because it's better for my brain to start with the starting point at the top. I'm moving from the starting point to the next one. So it's moving from 0.3 to 0.6. This is moving to right. Standing on the right hand firing is just one loop that it takes. Okay, 700 milliseconds, one loop moving from right 0.6 to the left 0.3. Okay, it takes 4 times of the walking cycle. that is 900 milliseconds. And fire left. I think it's all. I don't need this one. I think it's all right. Okay, we have changed only the um, entity, how the entity works. What we need to change is the rules. So npc anim x, it's used by this entity. This is the name of the entity. So let's move to the rules and change the entity. Okay, here we call instead of components is not, is animation, is the new package, and select first animation. I think it's correct. Okay, it's not here, it's here. Select first animation is okay. The next occurrence, animator, animation, select first animation, correct. The next is here, it's animation, the new package, animation. Instead of auto update is getting animation value. Next occurrence here, also it's animation package, animator class, and this action method is animation ended. Okay, it's the same, it's animation ended. Okay, next occurrence here, same animation, animator, switch animation. We have changed this method, it's called next animation. So entity a npc x, in the package animation class animator, it's calling the method next animation and creating this event. Okay, I hope I have changed all of them, and let's try it with the new classes. Okay, something it's not working fine. What's get animation value? Animation, animator, 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 get animation value. Okay, let's do it again. I need to the first one. Cannot set long field animation linear form in time to float. Long field mean time. Where is mean time? Oh, mean time is long. Yes. I think it's an issue, a mistake in the previous code. So it's long because time here in Java is a long value. Long. Whenever there is a mistake, the class is not correctly built, so it it doesn't work. So later on, it's providing a lot of mistakes, a lot of warnings and errors. So let's check. Okay, it's too fast. Okay, something is not working fine because it's doing the animation so fast. Okay, something is not working. Let me check because we have solved with the select first animation. Animator, select first animation. We have added animation recent at origin. So here is something related with the. Okay, let's do it this way. Animation time origin, get name. Animation time origin. Okay, that's correct. I don't know why it's called now. And cancel. We don't need this one. Refactor, rename now. So in some way, it's providing null value. So let me remove from this here, and let add that trace to here. So print the out value and get percentage. How it's called? Head loop percentage. Hmm. We don't have. We have get loop percentage. Okay, let's add this one. Okay, let's see what happens. Okay, so the output is just getting this value, so let's think that it's moving to the right. Get loop value 0.6 is the end. This is moving to the right. Hmm. It's doing it too fast. What's happened? So the values are correct. The loop times, it's one time, one time, one time, one time. Yes. Animation. Let's add more information here about the animation name. This animation name. Okay, just to check which animations are trying to show. So to right, fire front, to left, fire left. So it's moving from one to another, one to another. So I think the issue is here is ended because it's in some way just to saying that the animation has ended so fast. So its animation ended. So it does the first try and just in some way it says, okay, I have ended. So if you return is ended. So let's do a quick check, just saying that that is an infinite loop. So in this way, it's just keep moving to the right, but it cannot say that it has ended. Okay, it doesn't matter. Even if it's an infinite loop, it said it has ended. So I think the issue is there in this function is ended. Okay, elapsed time, and now minus the origin. So this is when we have reset the time, time range. It's the maximum minus the. Okay, the max time. Where is max time? Okay, this is a linear interpolation, so it's easy. Current loop, elapsed time minus this usually is 0. You have current loop integer time range. Okay, this is an integer division because this is a long. So you have the current loop. Perfect. The percentage is no, this is not. This is not correct. This is this way. Is the remaining time? No, yes. Get loop percentage is not this way. I think I change in keyframes. Get loop, get percentage. get percentage. Okay, this is this way, but this has a lot of keys, but it's more or less the same. So elapsed time minus, I think that this is not needed because we need to, okay, this is only the first time. I need to check this one in case that it doesn't, that is a delayed animation. So I need to recheck what happens if the starting point is not 0 and it's a delayed, because in that situation the minimum time is not equals to 0 and you need to use those values. So elapsed time minus, okay, divided, okay, and this is the remaining time, and you need to divide by the time range. So it's more or less this one. So elapsed time is the time that, so when we start the animation, we set the clock. So we can say, okay, it's 3 o'clock. So now it could be 3 o'clock plus 30 seconds. So the elapsed time is only 30 seconds. If the loop is 10 seconds, 30 seconds is 3 loops. So we get this one here. 30 seconds divided by 10 seconds. Integer division is 3, so it's loop 3. But for example, if we are 32 seconds and the loop is only 10 seconds, 32 divided 32 modulus 30, we get the remaining, so we get only 2 seconds. And 2 seconds divided by 30 seconds, we get the percentage. If the current loop is greater than loop times, null. Okay, I think that this way it's better. Okay, so I think it will work better now. No, it's not working better. It's doing also the same to right. So let's add a trace here. I think that we need information. Because the percentage is here and the problem is with is ended. Okay, I have modified this one but not this one. Is ended. Elapse is the same, so suppose the elapsed time is 32 seconds. Current loop is greater than loop times, return true. I think that we can use this one instead of doing twice. So so let's remove all of this one because it's the same code more or less. So what we need to return is the percentage get loop percentage. So get loop percentage now. So the percentage. So if current loop equals loop times, not exactly. Let's do this way. It's more or less the same, but not the same. So Boolean is the output is ended equal false, and we weren't going to return the ended. Okay. Percentage. If current loop is greater or equals, it doesn't matter in this case, then ended is true. So if we are in the last loop or last loop plus 1 or greater, then that is true. So we don't need the percentage. I don't care about the percentage. What I need is just to check elapsed time is long. Mhm. It's only to check the loop. I only need to check the loop. I don't care about the percentage, just to check if it has ended. It's still not working. Why? I think I have left the same code. Okay, better code. I need to move to debug this one. Okay, so let's do a debug. Okay. And there is a trace somewhere. Where is the trace? Okay, don't care. Go. Okay, and where we want to check? Here. Okay, so now is this long elapsed time animation origin now. So let's do elapsed time here is 24 milliseconds. The time range of the loop is, this is one of the big ones, this is 3.6 seconds. The current loop, okay, elapsed time, it's very small, so we are in one loop 1, 0, loop 0, number of loops 1, so it's not, so the ended is false. Okay, okay, okay. Okay, I know where is the problem. And how it works this engine is that the event is fire whenever you output anything valid. So false or true both are a valid output. If it's a valid output, so it doesn't matter. A valid output means that the next event must be fire. So it doesn't care if it's ended, it's true or false. The next event is fire, so its animation ended. It's always true. It's always uh, positive. Well done the event, so it's calling the next event, and we want to avoid that. So its animation ended. In all of them, its animation ended must return null. So this must be null. So we can do this way. Boolean is true. I think it's hard to work with this code this way. So I prefer that is ended provides correctly this one, and is animation ended here. We can add the code if is ended. If it's true, return out. If it's not, if it's ended, return true, out, true. If not, return null. I need to check this twice because it's not clear. It's not clear how to work with these null values just to avoid the next event. So I need to check who must take care about stopping the next event, just providing a null value. So maybe instead of providing that in here, maybe this code must be in the animator, that is who is providing all these informations. So just do if it's ended. mm, yes, just equals to false, and just to take care, because we want to provide any value, we want to continue the animations, not the animations, the next event, because the next event is just to switch the animation. So this is very related topic related with the game engine. Is I don't know if it's the best idea just to use the null to stop and continue, but it's the way that it works right now. So I need to take care of providing null if I don't want to fire the next event. So let me show you where is this one. Mm, Here, when it's animating here, the when it's trying calling the is animated ended. So whenever is animated ended provides any value, because the rules don't care if they are objects, floats, ints, integers, arrays, or whatever. It doesn't care what is the output. It doesn't care. Wherever valid output, then it fires this next event. NPC X percentage updated. So it's calling this one, and this event, output event, is the input event there, and it's calling the next animation. And that was the reason why it was switching from one animation to another again and again and again, because the issue was here. So it's very important that the actions that are called by the engine provide null values in this game engine. So let me, um, I think that I can move it back. So I don't care here. So I think I need only to care when I use the actions, because these are the methods that can be called from the event manager. So only these ones, it's need to check this ended. So okay, I think that it works. We have changed both animations. We have created the animation just to switch the picture, and we have changed the animation. So for example, imagine that instead of firing one time, we want to fire two times. Or for example, just instead of firing in the middle, we can just I'm trying to think of a quick animation. So let's stop. The only important thing here about the animations is that the end position of one animation must be the beginning of the next one, just to keep it a smooth movement. So we can add the animations wherever we want. So let's think any suggestions in the chat if you want to see. Maybe he can he can stop at the middle, or just stop in somewhere in some positions. Maybe we can split the walking and stop at the middle of the so let me check that. So it's important that we have two animations doing that. So we have one that changes the picture, and one just moving the character. So so when we move to left, we do this animation. So we can split it in two different animations and just add uh, a stop position in the middle. Yes, we can use the fire front again. So let's, for example, do that. So this is the left position. Just split the left movement in two different movements. To the left. Okay, no, sorry. And what I want to split is to the right. So when you move to the right, instead of going in one step from 30% of the screen to the 60%, just move to the middle, so 45%. So and here is 45. So we have split this in two. So we are going to take half time. So no changes here, to right, to right. Okay, it could be to right one and to right two. And do the same here, to right one and to right two. There's no changes here because it's the same animation, so no changes. And we want to add, for example, a fire front in the middle. Fire front in the middle, but we are at 45 because we are more or less in the middle of the screen. So fire front here between going to right, so fire front in the middle of the walking to the right. So I think that's it. So we have split the movement to the right in two parts, and between of them we have added a new fire. So that's the fire, the second going to right. So this way we can add whatever we want. So first fire and continue the walking. So we can add whatever we want, whatever the animation that we want. We can add other. It's very easy. More or less, an animation is just changing some properties of the objects, of the entities. So you can change the X position, the Y position, the size, or whatever. So it's more or less easy. This way of animations with keyframes of linear interpolation, it's very easy for this type of games. Okay, so right now it has a new animations, a new step. So it's only one animation with different steps. And what you can do, it depends of the tile sets that you have. So it depends on what the 2D artists have provides to you. So you can, in this case, I have some animations, but I can only use any of them. So I can only use any of these ones. Mhm. So we have used these two ones. There is no animation walking to the front because it's different. It's you need to animate a third parameter that is the Y position, the height. So if what's the position? So it's the X coordinate and the Y coordinate. So in order to do the movement to the front, you need to move down or move up a little bit the character just to provide some real animation walking to the front. If you want to do that, increasing the size, so if you start walking to the front and increasing the size of the character, it seems that it's walking to the screen, or walking far away, you can do it changing this one and do it a little smaller and smaller and smaller. That way it seems that is going far away from the screen. So more or less this is the animations that I have, and I think that's all for today. So uh, thanks for watching. I think that let me check interact. So we have migrate both the animations. There is a third animation, so I have not moved there. So but in the game, but it's the same, so it makes no sense to do it in live. So we have changed this animation is using the new packages, and we have add a new animation in the middle, so we have split the movement to the right and we have added this new fire here. But there is a second animation in this game is here, so I need to migrate also this one. And when you play it, even if you don't see it like an animation, when you are failing in this one, it's just changing the tile sets. So in some way, it's it's animating. So just changing the values of anything. For example, here, this animation, this is an animation. So this is another animation. Let me select a language, user instead animals. Okay, animals. Let me try. Uh, R. I don't know the name. What must be this animal? L. Sheep. Very easy. It was very easy. Here, elephant? No. Yeah. What can be done? Mm, no. O, U, N, a lemon, lemming. Ah, Fleming, Fleming, F, F, ah, Flemish. Okay, okay, it doesn't matter. I think I need to switch to another one that I know better, like fruits. Mm, it's a berry. This is strawberry. Okay. Okay. So that's it. So see you in next live. Thank you for watching. Thank you. Bye bye.